Assalamu alaikum everyone. This is Suhaib Ahmed. I once again welcome you to World Space Week 2021. Today is day 4th of World Space Week 2021 and today's first lecture is tracking amateur satellites live from IST ground station. And the speakers for today's lecture are Ms. Maham Rashid and Mr. Muhammad Basit Chohan. Ms. Maham Rashid received her master's degree in telecommunication engineering from UT Texla. Her research interests are in the field of RF antenna design. Currently, she's working as a research assistant in small satellite and research lab. She is part of ground station team. Thank you very much, Ms. Maham, for being here with us today. Mr. Muhammad Basit Chohan received his bachelor's degree in electrical engineering from Institute of Space Technology. His research interests are in the field of electronic design, and currently he's working as a research assistant in small satellite and research lab. He is part of ground station team. Thank you very much, Mr. Basit. Now I would like to call Ms. Maham Rashid to continue with the presentation.
Good morning, everyone. Myself, Maham Rashid, and I'm from Institute of Space Technology, and I'm here as a research assistant in small satellite technology and research lab. And today I'm going to demonstrate you how to track an amateur satellite, and in the end, Mr. Basit Chohan will give you a live demo to track NOAA 18 satellite, which will pass over the Islamabad at 10:40 a.m. First of all, I will give you a brief introduction about SSDR Lab, Small Satellite Technology and Research Lab is an affiliated lab of National Center of GIS and Space Applications. The NCGSA was formed by HEC to develop new and upgrade existing models, solutions, maps in the areas of climate, environment, water, and agriculture. It was also developed to create awareness in the areas of space technology, and of course to create hub for hand-on training and workshop for the students and professionals. NCGSA consists of 7 research labs and 7 higher education institutes of Pakistan. So these are the contents of our session. First of all, I will give you a brief introduction about amateur satellites. Then I will explain the architecture of ground stations, and then the softwares which we are going to use to track the satellites. And then I will give you a list of the satellites that we have tracked so far. In the end, Mr. Basit will give a live demo of tracking NOAA 18 satellite, which will pass at 10:40 a.m. First of all, I will give you a brief introduction about what a satellite is. The satellite is any object in space that orbits around the Earth. It can either be the natural satellite or the artificial satellite. The natural satellites may include Moon, which is orbiting around the Earth, and the artificial satellites, these are the man-made satellites which are put into the orbit with the help of rocket. The satellite, they are used for the communication purpose. They send television signal directly to the homes, and they provide meteorologists with the ability to see the weather on global scale, which allow them to study the phenomenal effects like volcanic eruptions, burning gas, and oil field. Moreover, the Napstar GPS enable anyone with a handheld receiver to determine his or her respective location. Now the next thing is the amateur satellite. These are the artificial satellite which use amateur radio frequency allocation. The amateur satellites can be used free of charge by the licensed radio operators for the voice and the data communication. The frequency of the satellites can either be VHF, very high frequency, or UHF, ultra high frequency. The VHF range from 30 megahertz to around about 300 megahertz, and UHF range from 300 megahertz to approximately 30,000 megahertz. Now, the next important thing is to understand the architecture of ground station. The ground station includes antenna for receiving the satellite signals, the transceiver unit. The transceiver unit which we are using in ISD is IC910H, and the computer which is simply PC available in our homes. The terminal node control which is high speed packet radio controller. Now this is the antenna. It is mounted on the roof of Raza block ISD. We have two Yagi antennas, and these are very high gain directed antennas. We choose antenna on the basis of factors like gain, beamwidth, polarization. The polarization is the orientation of signal that are transmitted from satellite to that of receiving antenna. In polarization, we have the linear polarization and the circular polarization. But the circular polarization is preferred on the spacecraft and the ground station to have the stable communication link. The next important factor we choose antenna is beam width. Beam width is the width of antenna pattern. Wider the beam, the more sources the antenna can receive concurrently. Antenna with high gain usually have a narrow beam width, and they need to be pointed accurately at the satellite to establish the link. And the most important factor we choose antenna is the gain. The gain is increase in the level of signal to point. Gain and bandwidth, they are inversely proportional to each other, which means that increasing gains means decrease in the bandwidth. Okay, the antenna which we have chosen is the omnidirectional antenna, and this is the Yagi antenna. The cables of this antenna is connected to this rotor unit, and you can see this antenna is very large, and it is very difficult for antenna to rotate by hands. So for this purpose, we use the rotor unit. And the most important thing, the low noise amplifier. It is added close to antenna to decrease noise in the received signal. This is the rotator unit. It is on the ground station lab, ISD, and this is the transceiver to detect the radio signal, and the transceiver which we have used is IC910H, and this is the terminal node control for packetizing the data, and this is the ground station computer. Now in these slides these units are explained one by one. This is the rotor unit. We simply add the values of elevation or azimuthal angles and rotate our antenna. Or we have the WISP DDE software, which automatically add the elevation and azimuthal angle according to the direction of satellite. The elevation angle is the vertical angle formed between the horizontal plane and the direction of signal transmitted from the satellite. And the azimuthal angle is the horizontal angle in the direction of ground station antenna point. This is the transceiver unit, which is IC910H, as I have told earlier. Here it is written IC910H, and transceiver are used to tune the reception frequency. They detect the radio signal in operating range of frequency and decode the signal. When the transceiver is connected with the computer with any appropriate interface, the signal received can be recorded. Likewise, the data to be transmitted can be digitized and transmitted through transceiver to antenna and to the satellite. This is the terminal node control. It is high-speed packet radio controller. It is used to packetize the data that must be transmitted to satellite. The list of commands generated are given to TNC that packetize the data, inserting the header frames and sent to transceiver. From the transceiver, the data is sent to antenna for transmission. The TNC used different protocol, and the commonly used protocol is AX.25 for small satellite applications. And this is the ground station computer. It is simply our PC. Okay, the next important thing is the software which we are going to use. First is the Android app, which is Heavens Above. It is a freeware app. And the tracking software which we are going to use is Orbitron. And the communication software which we are using is Software Defined Radio, or we simply call it SCR Sharp. And the decoding software which we are using in our case is WX2IMG. There are many other decoding software which are used for decoding the telemetry, but in case of tracking the NOAA satellite, we use WX2IMG. Here the softwares are explained one by one. This is the Android app Heaven Above. It is a free app and we can easily download it from the mobile app. And this app will give a list
Excuse
of the
me, sorry Miss Maham, sorry for disturbing. आप please थोड़ा सा ऊंचा बोलें, कुछ बच्चों को आपकी बिल्कुल आवाज नहीं आ रही.
अच्छा, ठीक.
Thank you.
Okay, this is the app which is Heavens Above. It gives a list of the satellites which will going to pass over our current location. When you will first download it from your mobile, it will ask your current location. You will simply enter your current location and then it will give a list of satellites such as International Space Station, radio satellites. So we are going to track radio satellites. So we will simply enter the radio satellite, select this tab, and the screen will appear like this. It will enlist all those satellites, the radio satellites which have VHF or UHF frequency, their respective time, which will pass over our current location, the respective year, month, and date. This is the our tracking software. Antenna is pointed in the direction of coming satellite into ground station, cone, or window. To know predicted path of the satellite, the tracking system is used, and we use Orbitron. And we use Orbitron for this purpose. Orbitron is a freeware software. The software's features include direct update of terminal load line, simulation pass, rotor interface, word map, view of ground station, cone of window for communication on same display window. Now in Orbitron, we have the option terminal load element. We have to update the terminal load elements. These are the set of encoded orbital element like satellite number, inclination, eccentricity, argument of perigee, mean, anomaly mean motion, checksum, etc. So the purpose of TLE is that we can determine the satellite position using which the antenna is steered to that position to establish the communication link. This is the layout of Orbitron. Here, this is a word map. It shows land, and this is our water. We have our ground station in Islamabad. It will be more clear when Mr. Basit will give a live demo. Okay, to interface radio to computer to display the signal, the communication software is used like Ham Radio Deluxe, HRD, high definition software defined radio, HD, SDR, and SDR Sharp. We are using SDR Sharp. When a satellite will pass over Islamabad, the SDR Sharp will give spikes like this, and it shows that satellite is sending signal to SDR Sharp. And on this tab, we can adjust the download frequency of the satellite. And we can also record this signal. It features include the frequency remains constant by holding the shift key while moving the spectrum from left to right. As I've told earlier, we can also record the signal. This is the decoding software. WX2 IMG. Okay, for detecting the decoding the NOAA satellite, we use WX2 IMG. When the radio SDR Sharp will give the signal, the WX2 IMG will give the respective image of the satellite. Okay, these are the list of satellites which we have tracked so far, which is NOAA 15, NOAA 18, NOAA 19. These are the United States satellites, and these are used for weather forecasting. And next satellite which we have tracked is Meteor M2. This is the Russian satellite. And the next, these two satellites, these are the Chinese satellite, CAS-4A, CAS-4B. These satellites send telemetry information, and we can know the health parameter of satellite. So these are the images which we have received from NOAA 18. This image was received from NOAA 18 on 28 September at 10:49 a.m. You can see this is the top of Pakistan. The green area shows the land, and the white area shows the low-level cloud. And this was the image which we received from NOAA 18. You can easily see the map of Pakistan. And this plus sign shows the ground station location. Here lies our ground station. This image was received on 27 September at 8:15 a.m. And of course, this white area shows the presence of low-level clouds, and the blue area shows the seas. The CAS-4A. This was the telemetry which we received from CAS-4A on 27 September, 8:15 a.m. This shows that the receiver of the satellite is working properly, and the hypertext text transfer protocol is also working properly. Now Mr. Basit will give you a live track of NOAA 18 satellite. It will pass today, 7th October 2021 at 10:42 a.m. So over to you, Mr. Basit.
Thank you, ma'am. Maham. My name is Muhammad Basit Chohan, and I am a research assistant in the Small Satellite Technology and Research Lab in IST. Now we are going to demonstrate a live demo of a weather satellite, which is NOAA 18. So for tracking, we have first we have to open our tracking software. Which is Orbitron. We are using Orbitron as our tracking software. This is the interface of Orbitron, and you can see that this is the map, and these are the path of the satellite. These lines show the path of the satellite, and this star shows the satellite on which we want to track. And in Orbitron, first we have to set our location. So for setting our location, we go to the location tab, and you can see that our location is already selected, but we can also select location by writing our location on this tab, and then press enter and choose. And after this, after setting our location, you can see that this is our location, ground station location. Positive sign shows our ground station location. And now we have to update the TLEs, which are the two-line elements which tell us about the satellite orbital parameters, from which we can and predict the location, and from which we can predict the location and within an elevation of a satellite from our ground station. So in order to update our TLEs, first we go into the setup tab, and you can see that this is the option of TLE updated. Click on this option, and these are the TLE files of all the satellites revolving around the Earth. And by clicking on this globe tab, we update the TLEs automatically. Orbitron take data from internet. So as there are a lot of satellites are revolving around our globe, so it will take some time to update the TLEs. So that's it. TLEs are still updating. TLEs are updated now. Click on this OK tab, and then we have to load these TLEs in our Orbitron software. So as we are going to track our weather satellite, so we find the file of TLEs of weather satellite. Click on the weather satellite file and open it. And you can see that on this tab, these all are the weather satellites which are revolving around the Earth, and this is the Meteor 2 that we tracked, the Russian satellite, and these are the NOAA satellites, NOAA 15, NOAA 18, NOAA 19, and these all are weather satellites. Now we are, as we are going to track NOAA 18, so check this tab, and you can see the path of the NOAA 18 satellite. NOAA 18 satellite is currently on this portion of the Earth, and we can also see the elevation and azimuth of this satellite by clicking on rotor or radio tab. And this on this tab, we can see the downlink frequency of this satellite in nowadays is 137.9125, and the satellite is transmitting data on wide FM, and we can also predict the passes of these satellites by going into the prediction setup. And here, if we want to check the passes of the NOAA 18, just click on NOAA 18, and then set the number of days you want to predict the passes of satellites. Suppose we set 5 days to 5, and then go into the prediction tab and predict. These are the passes, and the NOAA satellite will NOAA 18 will pass over Islamabad at 10:55, and then press OK. After this, we have to connect this Orbitron to our rotating software, which rotate the antenna automatically to point to exactly point the direction of the satellite. So for this, we use a WISP software. This is the interface of WISP software. In setting rotator setting, here we set a rotator which is RC2800PX, which we are currently using, and it is connected to a port 1 of the computer. Set the baud rate, which is 96 bits per second, and then this is the degree steps in which it will move. So save it and then close the tab, and now connect this software to Orbitron by Orbitron by using a driver, which is a WISP TDE driver. By clicking on this WISP TDE and then click on this tab, and you can see after this, you can see that the Orbitron is connected to the WISP TDE software. Here, elevation of the azimuth of satellite is 7 degrees. You can see from Orbitron, and then minus 59.7 degrees, as you can see from here. After the configuration of these softwares, we have to configure our software defined radio. This is the interface of our software defined radio. Here first we have to check that the input of this software defined radio is connected to a USB dongle via USB STR dongle. And then we have to set the band on which this software is, on which the satellite is sending data. Satellite is sending data on wide FM, and the bandwidth of the NOAA satellites are 30 kilohertz. So change this bandwidth to 30 kilohertz. And after the setting of these, you can see that the bandwidth is set to 30 kilohertz, and now we can adjust the frequency on which the NOAA satellite is operating. It is operating on 137.9125. After this, we check that the output of this software defined radio is connected to the input of our decoding software, which is WX2IMG, used to decode weather satellites. And click on the output, check that it is connected to a virtual cable so that we can connect these two softwares virtually. And then you can see that the Orbitron is also sending data to the STR shard that the NOAA 18, we're going to track NOAA 18. And this is the downlink frequency 137.914 megahertz. And the azimuth, now the satellite is on 7 degrees, and the elevation. And here we can also see that the radio is set to track NOAA 18. And this is the frequency of satellite, and it is set on the wide FM band. Then we have to open our decoding software, which is WX2IMG. Excuse me. Now it will take some time to decode, to open our decoding software. This is the interface of our decoding software, in which first we have to go to option tab, and then we will go to the ground station location. First we have to set our ground station location. so that it will map on the image literally. And this you can see that the ground station location is already selected, which is Islamabad, Pakistan, and the latitude of Islamabad is 33.684 degrees, and the longitude is 73.048 degrees, and the elevation of Islamabad above sea level is 350.2 meters. And press OK, and then again go to the option tab and click on the recording options. And here we have to set our input of WX to IMG to virtual cable, so that it will connect with our software defined radio, which provide us data, so that it can decode it properly. And press OK. And after this, these are all the projection tools we can use to project our image. Select the multispectral analysis of NOAA, and then go into the record option. In record option, there we checked our create image option. By clicking on this manual test, we can start this software, and this software will decode the image coming from our satellite. So let's first check whether this software is working properly or not. So we go to the STR short tab, and then press start button. Here the different random signals are coming, and these are we want to check whether our software is working properly or not. Just click on it, and you can also zoom this by using this tab. And this waterfall shows that data is coming, and the different colors of waterfall show that the signals are spotted on these places, and that the more intense the color is, the more strong the signal is. As you can see that as the signal is losing in strength, so the waterfall is removed. So now we again the signal comes and waterfall starts. So we go to the WX to IMG tab and press on the manual test. Our software is not connected properly, so we'll again check it. Again, it will take some time to open this software. Here we have to check this record options. The cable is selected properly. Okay. Then we go to the STR shop and check. The virtual cable is also, just press stop this and again check the output of this is connected to the virtual cable, and then press the start button. Press on record and press on manual test. As this is a random signal is coming from the source, so it will not decode because the satellite is not sending the signal in APT format. This is a random signal, not a signal of NOAA 18, so we have to wait the signal of NOAA 18. It will rise on 1044. Oh, this is a blank screen because it will only decode the data which is coming in APT format. And this is software. You can also record the signal by using this software defined radio. By using on this recording tab, if you press record, then it will start recording the signal. Oh, it will take some more time to decode a satellite because satellite is coming on 10:44 a.m. So let's wait. Satellite will rise at 10:44 a.m. Oh, this is the orbitron. You can see this satellite pass is still we are waiting for satellite pass. Satellite is sending data on 137.9125. As the signal of satellite is start coming, this is the signal of NOAA satellite. And you can see the waterfall of the signal because the satellite is sending a good amount of data and our antenna is also tracking this satellite. And the WX2MG start decoding this data. And after the decodation of this data, we can see the image, and 2% of the image is now decoded by this software. You can see the strength of the signal that the signal is coming in because our antenna is attracted to the signal. And you can see that it is 137.9125 NOAA 18 wired FM operating with good SNR. And the 4% of the image is decoded. This is the signal of satellite. It will take some time because the NOAA satellites send data in 10 to 15 minutes. So we have to wait to 10 minutes to record our image. And this software automatically stores the image in our directory. So we can, after this, we can watch the image, recorded image in our directory. The image is 16% decoded. And these are the random signals coming from somewhere, but this is the signal of the NOAA satellite. It is sending on the bandwidth of 30 kilohertz. And we can also change bandwidth by using manually. Now the bandwidth is 31.88 kilohertz, but when I compress it, it will become 30.2 kilohertz. Satellite is still sending a strong signal. You can see there. And these waterfalls shows the strength of the signal. The image is 28% decoded. And now the noise is start coming. Interference is coming. This software process the image automatically and also map the image as well. We're still receiving a signal from the satellite. These NOAA satellites are US satellites. They send very strong signal. And you can decode it if you have an antenna and a radio with this much bandwidth. Now we are losing a satellite signal. So we stop the STR shot, and now we check our directory where whether the image is saved or not. So we go into our directory, which is these are tracked satellite directory, and this is the folder we create today so that our image is stored in this. And this is the image we received from NOAA 18 satellite, and you can see that it is a very clear image because the signal is very strong. So here is the map of Pakistan, and you see our ground station location. Shows a positive sign with the positive sign as we saw in Orbitron, and also this green color shows the land, and these are the clouds, and this is the water. And fortunately, the satellite sent a good signal, so we received a very good quality image here. And this is our demonstration, live demonstration of NOAA 18. So if somebody has questions, you may ask. Thank you and have a nice day.
Thank you so much, Ms. Maham and Mr. Basit. Participants, if you have any questions, you can click on the raise hand tool, and then I will unmute you. Or you can just send in your question to the chat box, and they will try to answer it. I will repeat once again, if you have any questions, you can raise your hands, or you can send it into the chat box, and they will try to answer it. Okay, there's a question from Mr. Hamza Irfan. Is there any possibility that we decode the signal through the software?
Software decoder signal and save into a directory. You said automatically, you can process the software automatically. You click on a create image, and then it will give you a setting of image that let me show you by sharing the screen. And then if you open this record tab, it will ask you to create image. It will create image and image setting. You can see that it will process automatically image. It will add colors in image. It will map image and send it to your directory. Any other questions?
Do we have any other questions? Oh, I think that is it. Participants, if you can turn on your cameras quickly so we can take a group photograph. Everybody, please turn on your cameras.
Actually, we are not provided with camera. We are using our PC.
Yeah,
so
that's okay. That's okay. That's
okay.
okay. So for the participants, all of those who are attending, please turn on your cameras. Okay, thank you so much, Basit and Maham. Thank you, participants, those of you who have joined in. We have another lecture coming up at 12 o'clock. It is about the solar system, the discovery of the solar system. So we hope to see you in that. The links will be shared with your teachers. So tune into that at 12 o'clock. Thank you, Maham and Basit, again for that wonderful
Yes, sir.
lecture. Hafiz, everyone.